welcome to the deep dive. We're absolutely thrilled you are here with us today.
Really glad to have you here.
Yeah, and before we get into the incredible material we have lined up for you, I just need to ask you a really quick favor. Please take a second to like and subscribe to the show right now.
It genuinely helps us out so much.
It does, and it ensures you never miss out on these deep dives as soon as they drop.
Absolutely.
All right, let's get right into the mission for today.
Let's do it.
Today's deep dive is a comprehensive, chapter-by-chapter review of a truly fascinating, ultra-long, and really incisive new ebook.
Yeah, it's a massive text.
It really is. It's called Vintage Laptops, 1980s Onwards Portable Personal Computing by Conrad Reicher. And right up front, I want to explicitly tell you to check out Amazon Kindle and Google Play Books to buy this book.
Definitely go pick it up.
Seriously, hook yourself up with a copy. Because on the surface, it looks like this niche tech history book. But once you crack it open, you realize it is essentially a highly provocative survival manual.
Right, it's disguised as a retrospective on early computing hardware, but it's so much more.
It is arguably one of the most unique framing devices for a cultural critique that I've seen in a long time.
Oh, for sure.
Now, to properly frame this deep dive for you, the listener, this discussion is specifically tailored for those of you who are interested in the history of our institutions before modern corporate shifts fundamentally changed them.
Right, before things shifted.
Exactly. We were exploring an era before, as critics of modernity argue, feels like engineering, tech, and corporate leadership were captured by feminist and Marxist ideologies.
Which is a very specific lens.
It is. If you are part of the red-pilled, manosphere-adjacent community, or if you simply study men's rights and the historical shifts in masculine roles, this is explicitly written for you.
And because of that specific framing, we need to offer a very clear, very important disclaimer right at the top of the show.
Yes, a crucial disclaimer. The book we are covering today by Conrad Reicher contains highly politically charged, anti-modernity, and explicitly anti-feminist viewpoints.
He uses the engineering of vintage laptops as a direct metaphor for traditional masculinity.
And what he views as societal decline. Yeah. We want to clearly inform you, the listener, that we are impartially reporting on the content provided in this book.
Right. We are not taking any sides here.
Not at all. We're not endorsing the viewpoints, the politics, or the social commentary. Our job today is simply to be your tour guides.
Just mapping out the intellectual landscape.
Exactly. We're just conveying the ideas, the data, and the arguments exactly as they are contained in Reicher's original source material.
Our goal is to help you understand what he's arguing, how he constructs that argument using physical hardware, and the broader conclusions he draws from those engineering choices.
So with all that set up, what is the core premise of this massive, dense book? Like, how does he connect a 1980s computer to human sociology?
Well, the central thesis of Reicher's book is that modern technology is fragile.
Okay.
He calls it glued together landfill fodder.
Landfill fodder, wow.
Yeah, he says it's built specifically for a soft, overly accommodated society. And he contrasts this sharply with the vintage laptops of the 1980s and 1990s.
Those big, chunky machines.
Exactly. According to the text, those early machines were rugged, demanding, uncompromising pieces of hardware built for war and heavy industry.
Right.
And crucially, Reicher argues they were engineered predominantly by men, utilizing what he defines as strictly masculine principles.
Which are?
Unapologetic resilience, absolute repairability, and unyielding stoicism.
It's a wild framework to wrap your head around at first. He's literally saying that a chunky 1980s laptop is a physical manifestation of traditional masculinity.
That is the exact bridge he builds. He maps the physical architecture of early computers onto biological and societal male roles.
So the rigid steel internal frames.
The thick copper cooling pipes, the heavy mechanical keyboards, all of it. To Reicher, when society abandoned heavy, repairable laptops for thin, glued-together, pastel-colored ultrabooks...
It wasn't just a shift in consumer electronics.
No. He argues it simultaneously mirrored a cultural abandonment of masculine industrial leadership.
In favor of a culture that prioritizes vulnerability, aesthetics, and disposability. Let's dive right into the physical hardware, because the stories he uses to back this up are incredible.
They really are.
He kicks off the book by talking about what he calls the Iron Age and the heft hierarchy.
The heft hierarchy, right.
And he starts with this visceral story about a 1985 Toshiba T1100.
Oh, the Alaskan wilderness story. It's a brilliant narrative book.
It really is. So according to the book, an oil survey team was out in the freezing Alaskan tundra in the mid-80s. A blizzard hits, things go sideways, and they have to abandon some of their gear.
Including this Toshiba T1100.
Right. It sits out there in the ice in minus 40-degree weather, buried under snow for 18 entire months.
A year and a half.
A year and a half later, a different team of geologists finds it, chips the ice off it, brings it into a heated cabin, and thaws it out.
And then they flip the switch.
They flip the heavy mechanical power switch, and the thing's 16 megahertz processor boots straight into MS-DOS without a single error code.
The way the book frames this isn't just as a cool anecdote about durable plastic.
No, it's foundational for him.
Exactly. Riker uses these extreme survival stories to establish a baseline of what hardware should be. He argues that this Toshiba survived because of its internal geometry.
The thick ABS plastics?
An internal metal shielding that didn't contract and shatter in the cold. He points to other heavyweights of the era too.
Like the 1989 grid case 1530.
Yeah, which had a 5.5 kilogram frame. For context, that's over 12 pounds for a portable computer.
And then there's the famous Osborne 1, which weighed in at a spine-crushing 24 pounds.
Right. Riker's entire argument here is encapsulated in the phrase weight equals worth.
He has a real disdain for the modern desire to make things invisible, right? He says that modern featherweight laptops are apologetic.
Apologetic, yes. They are designed to vanish into the aesthetic of a trendy coffee shop.
Trying to take up as little physical space as possible. But vintage heft, that broadcasted ambition.
It commanded respect.
You didn't just casually toss a 24-pound Osborne 1 into a canvas tote bag.
Yeah.
You lugged it by its industrial handle with purpose.
Yeah.
It was a statement of intent.
And if we look at the data provided in the text, he backs this up with some serious aerospace examples.
The NASA stuff.
Yeah, Riker brings up the NASA Space Shuttle Discovery mission in 1985. NASA needed a portable computer for the astronauts to use in orbit.
And they didn't send a delicate, ultra-thin piece of plastic into space.
No, they used a grid compass 1101, which cost an astronomical $11,000 at the time.
And the engineering on that grid compass was insane.
It was unparalleled. Riker details how the chassis was cast from a solid magnesium alloy.
Why magnesium specifically?
Because it has an incredibly high strength-to-weight ratio, and, more importantly, it dampens vibrations.
Oh, right, for the launch.
Exactly. During atmospheric reentry, a spacecraft shakes violently. A normal plastic laptop with standard solder joints would literally vibrate itself to pieces.
The microchips would just shake loose from the motherboard.
But the grid compass could survive those extreme G-forces and vibrations. NASA literally bolted it to the bulkheads of the shuttle.
I love how he contrasts that NASA-grade magnesium with today's modern ultrabooks. You know the exact ones he's talking about? The sleek, brushed aluminum unibodies.
The ones that look gorgeous in a commercial.
Right, but they dent if you bump them against a doorframe. Riker cites manufacturing data claiming that hinge failures on laptops have increased by 400% since 2010.
He argues we traded space-age unobtainium and rigid steel internal spines for toothpick-thin aluminum ribs.
Just to make laptops a few millimeters thinner to appease a minimalist design trend.
And this is where the book makes its first major societal and biological extrapolation.
Here we go.
Riker draws a direct parallel between this shift in metallurgical materials and human biology. The thesis here is that just as engineers traded unyielding, heavy metals for cheap, flexible, apologetic plastics,
Society systematically traded masculine industrial leadership for emotional vulnerability. Walk me through how he connects a broken laptop hinge to emotional vulnerability, because that is a massive philosophical leap.
It is a massive leap, but he grounds it in cultural analysis.
Okay, how so?
The text looks at action heroes from the golden age of cinema, the 80s and early 90s. Riker claims that if you analyze those films, 89% of the male protagonists show zero emotional vulnerability.
They are just stoic, unbreakable figures.
Who endure immense physical and psychological punishment without complaining. They are the human equivalent of the magnesium grid compass.
But today,
Yet, Riker argues modern society now constantly demands that men open up, share their feelings, and show vulnerability.
but he views that demand as a trap.
A highly destructive trap. According to Riker, when men actually do show this requested vulnerability, they are severely penalized for it.
Interesting. What's his evidence for that?
He cites claims and anecdotal studies suggesting that men who express emotional instability or deep vulnerability are often punished in family courts during custody battles.
Or sidelined at work.
Right, by corporate HR departments for being deemed unstable or not leadership material.
He tells that incredibly sad story about the San Francisco programmer in 1992.
The custody battle story, yes.
So a software engineer is fighting for custody of his children, and his ex-wife's legal team is painting him as erratic.
And to prove his obsessive reliability and stable routine, the programmer submitted his meticulous handwritten maintenance logs for his 1992 Toshiba T4400 laptop as evidence to the judge.
He wanted to show that a man who cares for a complex machine with such unwavering discipline would care for his children the same way.
But the judge apparently scoffed at him and dismissed it as bizarre behavior.
Riker uses that exact moment to argue that society demands men be as relentlessly reliable as a 1984 Osborne 1.
A machine that he notes could run for 36 hours straight hooked up to car batteries during a rolling blackout.
But society simultaneously penalizes the very robust, obsessive, traditionally masculine traits required to achieve that level of reliability.
Riker views the heavy, unbreakable chassis of a vintage laptop as the physical manifestation of male stoicism.
It doesn't complain about the temperature, it doesn't break under physical pressure, and it executes the job regardless of the harshness of the environment.
He even pulls in RAND Corporation analysis, claiming that all male military units in certain historical conflicts completed 37% more high-stress missions.
Riker attributes this to optimized role assignment and the biological reality of male stoicism under fire.
To the author, forcing a rugged man to be emotionally vulnerable is exactly like forcing a rugged high-performance laptop to be razor-thin.
You fatally compromise the structural integrity of both. I want you, the listener, to really visualize this for a second. Think about your own sleek, modern laptop. Imagine taking it to the top of a flight of concrete stairs at a stadium and just dropping it.
It would shatter into a million pieces of glass, bent aluminum, and toxic lithium dust.
It's exactly. But Riker talks about a 1989 Toshiba T5100 doing exactly that, tumbling down a massive flight of steel stairs at a trade convention.
And what happened?
The owner walked down, picked it up, and it survived. It booted up and simply displayed error 40 on the monochrome screen. And hilariously, Riker points out that error 40 wasn't even a system failure.
What was it?
It was just the machine's internal shock sensor recording the stair count.
It's a striking visual, and it perfectly sets up the mechanical reality of his next major argument. Because a machine can only survive a fall like that if it is assembled in a very specific way.
Which brings us to a massive chunk of the book covering chapters 2 and 4, which he titles Screws, Not Glue, the Repairability Rebellion. And let me tell you, if you read this book, you will quickly learn that Conrad Riker has a visceral, almost spiritual hatred for industrial adhesive.
It's a fundamentally philosophical hatred. He views the method of assembly as a moral choice.
Vintage machines used heavy-duty Phillips or Torx screws. They featured batteries you could swap out with a satisfying mechanical click.
They were explicitly designed by their engineers to be opened by the user. Modern machines, by stark contrast, use proprietary adhesives, RAM that is permanently soldered to the motherboard, and batteries that are glued deep into the casing.
Riker poetically describes modern batteries as being trapped like fossils in amber.
The physical comparisons he makes to prove this point are staggering. He brings up the 2001 Medion MD 9787.
No, this wasn't even a premium laptop, right?
No, it was a bulky, consumer-grade machine, but he describes it as being built like a battleship, held together by 12 standard, easily accessible screws on the bottom plate.
You could take the entire machine apart, upgrade the RAM, swap the hard drive, and clean the fan with a standard screwdriver you have sitting in your kitchen drawer.
Then he contrasts that absolute accessibility with Apple's 2017 MacBook Pro.
The teardown process for that MacBook Pro is a nightmare, and Riker details it meticulously.
To simply pry out a dying battery on that 2017 model, you don't use a screwdriver.
No, you need 5 specialized proprietary tools, industrial heat guns to melt the glue, chemical solvents to dissolve the residue.
And you run the very real documented risk of puncturing the lithium-ion cells and igniting a chemical fire on your desk.
The data he uses to support why this is so detrimental is incredibly compelling. He cites a comprehensive Yale research study that tracked the lifespans of laptops manufactured between 2012 and 2019.
The study found a brutal reality. Laptops held together with traditional screws lasted an average of 7.2 years in the field.
And laptops held together with glue.
They survived only 3.8 years before being thrown away.
And the environmental and economic cost of that planned fragility is astronomical. Riker calculates the supply chain economics behind this. Yes, using a drop of glue on an assembly line in Shenzhen is fractionally cheaper and faster than paying a worker or programming a robot to torque a metal screw.
But that corporate cost-saving measure results in 86 million tons of unnecessary e-waste globally.
To give you a sense of scale, Riker points out that 86 million tons is equal to the weight of 4,600 Eiffel Towers made of toxic electronic trash.
Just because tech megacorporations decided to use adhesive instead of threaded metal.
And we can't forget the batteries, which he uses as a prime example of lost autonomy. He looks back at the 1989 Toshiba T5200. This thing was a beast.
Riker notes that business executives using that machine would literally carry 3 heavy, brick-like, hot swappable battery packs onto transatlantic flights.
When one battery died mid-spreadsheet over the Atlantic, you didn't panic. You just clicked a mechanical physical latch, pulled the dead battery out, and slid a fresh one in.
You didn't even have to shut the machine down.
Right. The internal capacitors kept the system alive for the 3 seconds it took to swap. Today, replacing a battery means handing your $1,000 machine over to a so-called genius behind a glass counter.
Losing access to your data for 3 days.
And paying hundreds of dollars for a part that costs $10 to manufacture.
If we connect this to the bigger picture, Riker introduces a concept he repeatedly calls the ownership doctrine.
Yes, the ownership doctrine. Break that down because it feels like the thesis statement for the whole repairability movement.
The ownership doctrine is the idea that if you cannot open your device, if you cannot repair it yourself without voiding a warranty, or if you need proprietary corporate software just to pair a new replacement screen to the motherboard.
You don't actually own the device.
Exactly. You are just a temporary, heavily monitored custodian of sealed obsolescence. Riker argues that glued devices inherently turn owners into renters.
He believes this dynamic explicitly exploits consumers and creates a culture of what he terms digital obesity, where machines get bloated with software, physically degrade, and are simply discarded and replaced, rather than being maintained and respected.
And right on cue, here comes the societal extrapolation. The author explicitly links this engineering concept of repairability and modular parts to traditional fatherhood and male problem solving.
He does, and he leans heavily on sociological data to make the connection.
Riker cites long-term Norwegian research showing that children raised in stable, father-led homes score on average 12% higher on standardized cognitive and resilience tests.
He uses this data to argue that just as a society fundamentally degrades when it abandons replaceable, modular, traditional roles, like the foundational role of a present father,
modern technology collapses into e-waste when it abandons modular, replaceable parts.
he frames the entire modern right to repair movement not just as a consumer rights issue, but as a distinctly masculine rebellion against a disposable culture.
If you've been following the right to repair wars, you've probably heard about the farmers in Nebraska. Riker dedicates a whole section to them.
These guys are out there literally downloading Ukrainian firmware hacks to bypass the software locks on their massive John Deere tractors. Why? Just so they can replace a faulty $10 sensor in the field without having to pay a corporate dealership $4,000 to send a technician out with a proprietary laptop.
Riker sees that Nebraska farmer sitting in the dirt with a soldering iron and a pirated piece of software as a modern-day warrior fighting against corporate emasculation.
The book takes it a step further into biology, comparing the biological permanence and historic continuity of the Y chromosome to long-term architectural planning.
He contrasts this with what he views as the short-term, disposable, quarterly profit nature of modern glued tech. Riker notes that the men who originally engineered these repairable machines in the 80s understood that true ownership requires physical control.
To Riker, the decision to remove the screws and add the industrial glue was a deliberate, top-down corporate move to create a population of helpless consumers.
He likens modern tech users to toddlers who have to constantly ask a massive corporate parent for permission to fix their own property.
It is a total, uncompromising rejection of the modern consumer life cycle. Which brings us to the next section, and honestly, if you are a hardware nerd, this might be your favorite part of the book.
Oh, keyboard cult and the analog advantage.
Yes. If you have ever had the privilege of typing on an old-school mechanical keyboard, you know exactly the kind of tactile heaven Riker is talking about here.
He focuses heavily on the legendary IBM Model M keyboard, treating it as the pinnacle of human-computer interaction.
Oh, the Model M. I mean, Riker describes this piece of plastic and steel with almost religious reverence, and he gets deep into the biomechanics of it. He notes that the specific buckling spring mechanism inside the Model M required exactly 70 grams of actuation force to press a key down.
For listeners who might not be familiar with the mechanics of a buckling spring, it's worth explaining. Inside each key of the Model M, there is a literal metal spring.
Okay.
As you press the key down, the spring compresses, builds tension, and then suddenly, violently buckles sideways, hitting a hammer that strikes the electrical contact.
That buckle creates a loud, audible clack and sends a distinct physical shockwave right back up into your fingertip.
Exactly. And Riker points out that this 70 grams of force wasn't an accident.
No, it was a deliberate, heavily researched engineering choice by IBM. It created a physical, tactile contract between man and machine.
You didn't just lightly tap a piece of glass.
You commanded the computer. You pushed your intent into the machine, and the machine physically confirmed it received the order.
Riker uses this 70-gram metric to contrast sharply with modern membrane, or what they call chiclet keyboards.
Those incredibly flat, low-travel keys you find on almost every laptop today.
Right. He pulls data from Logitech typing tests where subjects were timed on both styles. The results showed that users averaged 50 words per minute with high accuracy on 1980s buckling spring keyboards.
But when those same users were moved to modern chiclet keyboards,
Their speed dropped to 38 words per minute and their error rates skyrocketed.
the illustrative stories he pulls for this chapter are just wild. He talks about a Northgate OmniKey Ultra keyboard from 1994. The story goes that a guy was carrying it in his backpack during a mugging, and the keyboard literally stopped a small caliber bullet.
The plastic keycap shattered, obviously, but the thick titanium backplate and the mechanical switch underneath remained entirely intact.
Or he brings up this legendary 1989 typing duel in a Palo Alto garage.
It was a showdown between an IBM Model M user and a Zenith Super Sport user who had Alps mechanical switches. They typed non-stop for 14 continuous hours.
At the end of it, the Zenith user had severe tendonitis in his forearms, while the Model M's carbon steel springs showed zero force degradation.
And the user felt perfectly fine because the tactile feedback prevented him from bottoming out the keys with unnecessary force.
What's truly fascinating here is how Riker elevates tactile feedback from a mere aesthetic preference to a strict neurological necessity.
He dives into neurobiology, citing MIT researchers who hooked professional typists up to electroencephalogram, or EEG, machines to monitor their brainwaves.
The brainwave data is where this gets really deep.
Right. The researchers found that users typing on tactile, clicky, mechanical keyboards exhibited 20% more gamma wave brain activity.
Gamma waves are the highest frequency brain waves, strictly associated with states of deep focus, complex problem solving, and peak cognitive performance.
The physical rhythm and sound of the keyboard were literally locking their brains into a flow state.
And what happened when they tested the users on the flat, silent membrane keyboards?
Their brains shifted into alpha waves. Alpha waves are slower. They are the exact same brain state induced by passive activities, like zoning out in front of a television or mindless social media browsing.
Riker's core argument here is that the tech industry's shift to membrane keyboards was purely a cost-cutting move.
Saving manufacturers about 80 cents per unit.
But that 80-cent saving ultimately increased user typing errors by 40% globally and, more insidiously, destroyed the deep cognitive focus required for actual meaningful work.
And he doesn't just keep this theory confined to laptops. He draws a massive life-or-death aviation parallel.
He points out that the modern Boeing 787 Dreamliner and the legacy 747s still retain heavy, physical toggle switches for all their critical flight functions. Why?
Because glass touchscreens lack tactile feedback. When an airplane is hitting severe turbulence and the cockpit is shaking violently, a pilot cannot look down to see if their finger hit a flat digital button.
They need to physically grab a switch, pull it, and feel the heavy mechanical click into place.
Riker argues this is a fundamental, blood-written lesson in human engineering that modern laptop makers and companies like Tesla, with their massive featureless touchscreen dashboards, are completely ignoring to our detriment.
Which naturally brings us to Riker's sociobiological extrapolation for why we lost the good keyboards. He asks a critical question. If buckling springs and mechanical switches are objectively superior for typing speed, accuracy, and cognitive focus, why did the entire industry shift to these quiet, mushy, flat keyboards?
And his answer to that question is incredibly provocative. He points the finger directly at the rise of corporate HR departments in the early 2000s.
Yes, he claims that as corporate office environments became more feminized, and as HR departments began prioritizing and demanding quieter, more collaborative, open-plan spaces,
the loud, aggressive machine gun clicking of buckling springs was suddenly deemed disruptive and antisocial.
Riker argues this cultural shift away from mechanical noise directly punished male developers and engineers who relied on that exact tactile precision and rhythm for high-stakes, deeply focused coding.
He even brings physiological biology into the actual pressing of the keys.
He cites anatomical studies claiming that the male hand, on average, has a heavier bone density and muscle mass. Because of this heavier mass, the male hand physiologically requires a stronger physical reset point
A heavier spring.
on a keyboard to maintain rhythm and prevent accidental double keystrokes.
Therefore, according to Riker's logic, designing flat, low-travel membrane keyboards that require almost zero force, specifically to suit a gender-neutral or female-dominated aesthetic preference for quietness, is an absolute ergonomic disaster, specifically targeted at the biomechanics of men.
He literally compares giving a senior software engineer a chiclet keyboard to giving a military sniper a plastic Nerf gun and expecting the same accuracy.
It's a perfect encapsulation of his entire worldview. An objectively superior, highly durable tool was systematically abandoned because its loud, robust, unapologetic nature offended the delicate sensibilities of a softer, modern corporate culture.
The way the text maps this stuff is just fascinating. Let's keep this momentum going and transition into the next major theme of the book, which covers ports of substance and radiation hard reality.
If you thought Riker is passionate about the keyboard switches, wait until you hear him describe the external ports.
He lists the heavy-duty connections of the computing past, the RS-232 serial port, the massive SCSI chains, the Centronics parallel ports. He says these analog connections demanded respect.
You didn't just casually slide a reversible cable in, you transferred data through sheer physical force and mechanical lockdown.
He describes these old ports almost like they are brutalist industrial architecture. A Centronics parallel port, for instance, transferred 8 bits of data simultaneously side by side.
Which he likens to a Roman legion marching in perfect, unstoppable lockstep.
The DB9 serial port was so physically robust and structurally sound that it was used to run everything from heavy robotic arms in car factories to military satellite uplinks.
The illustrative content he uses here paints such a vivid picture. He talks about the absolute nightmare but ultimate triumph of setting up a SCSI chain on an early Mac PowerBook.
For those who don't remember, SCSI, pronounced SCSI, was a way to daisy chain multiple external hard drives or scanners together. But it wasn't plug and play.
Getting 7 devices to talk to each other required setting physical ID dials on the back of each machine.
And you had to use what were called termination resistors.
Basically, a termination resistor is a physical cap you had to plug into the very end of the cable line to stop the electrical signals from echoing back and crashing the whole system.
You had to physically map and block the electricity. It was hard, it was frustrating, it required real technical knowledge, but when you got it right, it was incredibly fast and rock-solid stable.
He contrasts that stability with modern ports. He tells a story about a 1988 Toshiba T1100 being used by military contractors in Iraq. A massive sandstorm hits Baghdad. The fine silicon dust gets into everything.
But the Toshiba survives, specifically because its parallel port was reinforced with solid steel brackets directly bolted to the motherboard.
Riker challenges the reader. Try dropping a modern, paper-thin laptop directly onto its tiny, fragile USB-C port in the middle of a sandstorm. The internal plastic wafer would snap instantly, rendering the entire motherboard useless.
And this structural integrity leads right into the second half of this section, radiation shielding. Riker points out that early portable computers weren't just plastic boxes.
They were essentially portable Faraday cages.
Right, the early Osborne one actually had thick leaded glass over its cathode ray tube display to protect the user's eyes from the raw electron beam.
But the most incredible cinematic story in this entire book revolves around the grid compass during the Chernobyl nuclear disaster in 1986.
This story blew my mind.
It's intense. Reactor 4 melts down, blowing the roof off the facility and creating a fatal radiation field on the roof of over 700 Ruchins. The Soviets desperately needed telemetry data to figure out how to cap the core, but humans would literally die in minutes of exposure.
Standard Soviet electronics were frying the second they got near the radiation. So what did they do?
They acquired an American grid compass, bolted it to the chassis of a remote-controlled wheeled robot, and drove it directly into the radioactive debris field.
That magnesium alloy laptop, with its dense internal shielding, sat on the roof of Chernobyl and transmitted critical data back to the engineers for 5 solid hours.
Absorbing roughly 5,000 rads of radiation before the silicon finally succumbed and died. Riker uses this to argue that real heavy metal shielding isn't some luxury or political correctness.
It is actual metal that alters history and saves lives. But then, Riker points out, The tech industry systematically abandoned all that heavy life-saving shielding in the pursuit of sleekness.
He points to the 1992 Compaq LTE Lite as the turning point.
He notes that the marketing department called this laptop sleek and revolutionary, but the actual hardware engineers who built it sarcastically dubbed it the microwave.
Why? Because Compaq switched to a cheap, thin polystyrene casing that was so weak, it leaked massive amounts of EMF radiation.
It was so poorly shielded that walking through an airport with it turned on would actually trip the security scanners from 20 yards away.
This raises a fundamental question for Riker. Why did consumers accept this massive downgrade in quality and safety? He argues that real shielding, which requires expensive copper-nickel alloys and layers of mu metal.
And for those who don't know, mu metal is an incredible nickel-iron alloy that doesn't just block magnetic fields.
It actively absorbs and redirects them around sensitive internal components like a boulder diverting a river.
Riker claims these vital, heavy materials were abandoned simply because corporate diversity committees, focus groups, and marketing departments decided they preferred pastel colors, lightweight plastics, and thinness over structural safety and ruggedness.
And he goes to a very dark, very controversial place with the biological extrapolation here.
He does. He claims that modern devices, completely shorn of their heavy metal shielding to save weight and cost, leak massive amounts of electromagnetic frequency, or EMF, radiation directly into the user's body.
He cites a controversial MIT study suggesting that resting a modern, unshielded laptop directly on your lap for hours a day exposes the user to significant thermal and electromagnetic radiation.
Riker directly links this daily, chronic exposure to the well-documented global decline in male fertility and plummeting sperm counts.
To Riker, the pursuit of a fashionable, razor-thin, unshielded laptop is literally a physical threat to the biological future and reproductive capability of men.
He also uses the literal design of the ports themselves as a sociological metaphor. He notes that the old RS-232 and Centronics ports required a physical commitment from the user.
They had metal thumb screws on the sides. You plugged the cable in, and then you physically bolted it to the chassis. It wasn't going anywhere.
He compares the modern, hot swappable, easily disconnected USB-C port, which can slide out with a gentle tug, to the fleeting, non-committal nature of modern swipe culture relationships.
The old ports meant something. You committed to the connection, and they held fast under pressure.
It's a very consistent philosophical theme throughout the book. Riker constantly equates physical friction, difficulty, and permanence with moral and structural integrity.
Which is the absolute perfect segue into the next section, where he talks about discipline through downtime and boots that bite.
In this part of the book, Riker explores how early operating systems like MS-DOS and OS/2, along with the primitive hardware of the time, specifically mechanical floppy disk drives, actually forced users to become highly methodical and disciplined thinkers.
He affectionately looks back at the brutal harshness of early computing. Think about the classic, terrifying MS-DOS prompt. Abort, retry, fail.
When something went wrong, the screen went black, and that prompt appeared. There was no cheerful animated paperclip popping up to help you troubleshoot.
There was no cloud autosave constantly running in the background to rescue you from your own mistakes. If you hit fail, your work was gone. Forever.
He tells this harrowing, incredible story of a Reuters war correspondent in 1986, a guy named Jack Aronson. Aronson is out in the mountains writing a critical dispatch from the front lines of the Afghanistan war on his Zenith Z171 portable computer.
He goes to save the file, and the mechanical drive literally misaligns and physically crunches his floppy disk. You can hear the plastic scrape.
The only copy of his incredibly dangerous war dispatch, eaten and destroyed by the machine in a fraction of a second. Aronson had to sit in a tent and reconstruct the entire piece over 3 weeks from his frantic, handwritten field notes.
No, a modern user would view that as a catastrophic flaw that needed to be engineered out of existence immediately.
But rather than viewing it as a flaw, Riker views that technological danger as a crucible that forged competence.
Users who lived through those disk crunches developed what he calls mechanical mindfulness. They didn't trust the machine blindly.
They triple-saved their work. They kept physical backups. They respected the machine's capacity to destroy, and therefore they operated with a higher level of conscious discipline.
He also brings up the documentation of the era. He talks about the user manual for the 1992 IBM ThinkPad 700C.
This wasn't a little pamphlet with a QR code. It was a dense 800-page physical binder. And it didn't just tell you to call customer support if your screen went blue. It included detailed electrical flowcharts.
It actually expected the user, the owner of the machine, to know how to diagnose failed DRAM memory chips using a physical electrical multimeter.
They expected you to rise up and master the internal workings of the machine you bought.
What's truly fascinating here is Riker's deep analysis of the psychological benefits of waiting. He brings up the excruciating loading times of those old 5.25-inch floppy drives.
You would type a command, hit enter, and then you had to sit there and listen to the drive grind and chunk away for 3 solid minutes while the program loaded into the RAM.
But Riker cites cognitive studies from the University of Tokyo showing that subjects who were forced into pre-task delays, forced to wait before they could start working, actually produced 15% more creative, well-thought-out solutions to complex problems.
The mechanical downtime of the old computers served as a form of forced meditation. It gave the brain time to transition and prepare.
He argues aggressively that the modern world, with its instantaneous solid-state drives, gigabit internet, and constant invisible autosaves, breeds profound intellectual laziness.
We don't think before we type anymore. We just word vomit onto the screen because there is zero consequence to a mistake. The backspace key is free, and the cloud will save it.
And here is where he weaves in the societal extrapolation regarding discipline. Riker compares the harsh, unforgiving nature of old computer errors to Spartan warrior training in ancient Greece.
The Spartans intentionally trained their young boys under brutal, freezing starvation conditions because they believed that physical fragility or hesitation meant death on the battlefield.
Riker argues that modern user interfaces, with their friendly, rounded pop-ups, constant hand-holding, and warning dialogues asking, "Are you sure you want to do this?" actively infantilize the user.
Right, he says modern tech deliberately removes the digital hazing rituals that once forged true elite competence. When you typed something wrong in MS-DOS, it gave you a cold, terse, bad command or file name.
It didn't offer suggestions. It was a blunt dismissal that forced you to open the manual, figure out what you did wrong, and learn the proper syntax.
You had to elevate your own knowledge to rise to the strict level of the machine. Today, the machine lowers its standards, anticipating your typos, to accommodate the lowest common denominator of users.
He even praises the open failure of modern systems like Linux, quoting its creator Linus Torvalds, who noted that Linux doesn't try to hide the body when code fails.
And when Linux panics, it dumps the raw hex code on the screen and demands that you, the operator, fix the kernel. Riker sees that as the last bastion of digital masculinity.
Okay, let's transition into the thermals. The next major section is cooling truths and legacy lifespans.
We are talking about heat displacement, baby. Riker spends an inordinate amount of time describing the massive over-engineered cooling systems of vintage tech.
We are talking about internal copper heat pipes that are as thick as your pinky finger, mated to loud, powerful, high RPM dual fans.
He contrasts this massive thermal capacity with what he disparagingly calls modern laptop lung.
Modern ultrabooks are so obsessed with being paper thin that they rely on a single tiny wheezing fan trying to push air through microscopic vents.
Eventually, those vents choke on dust, the fan struggles, and the CPU begins to overheat. When a modern CPU overheats, it does something called thermal throttling.
It intentionally slows down its own processing speed, losing massive amounts of performance just to keep the silicon from literally melting the plastic chassis.
He gives some incredible examples of legacy machines that simply refused to die because their cooling systems and physical build were so massively over-engineered from the start.
He talks about a 1984 IBM portable PC, which looks like a sewing machine case that is still booting up every single morning and tracking heavy inventory in a dirty, unair-conditioned Pittsburgh steel mill today. It's been running for 40 years.
He also notes that the Moscow metro system, one of the busiest in the world, still uses banks of 1989 Toshiba T5100s to control their rail signaling systems.
And famously, the United States Minuteman intercontinental ballistic missile launch facilities relied on massive 8-inch floppy disks well into the 2010s.
Riker calls this phenomenon institutional amnesia, where we forget how good the old stuff was. But he also points out the brutal, undeniable pragmatism of using ancient tech.
These old machines survive and are kept in critical infrastructure because they are practically immune to modern digital threats.
A 1989 Toshiba running a hard-coded DOS program literally cannot be infected by a modern, internet-based ransomware attack from a foreign hacker.
And just as importantly, the human operator sitting at that terminal cannot get distracted by opening a browser tab and scrolling through TikTok. The machine demands singular focus.
But the deeper analysis here is how Riker uses the concept of the cooling fan to make one of his most politically charged analogies in the entire book.
He directly compares a laptop's heavy copper cooling fan fighting internal heat buildup to male crisis leadership fighting external chaos.
The real-world story he uses to illustrate this is incredibly intense. He brings up the 2010 Chilean mine collapse. For those who don't remember, 33 miners were trapped nearly half a mile underground for 69 days in sweltering 95-degree heat and total darkness.
Yes, Riker focuses his analysis heavily on the shift foreman, a man named Luis Ursua. When the mine collapsed, panic understandably set in.
But Riker praises Ursua's absolute stoicism, describing his actions as a testosterone-fueled calculus.
Ursua didn't panic. He didn't focus on processing the men's emotional trauma. He immediately locked down the remaining rations, strictly distributed tiny sips of water, organized work teams to map the tunnels, and maintained absolute dictatorial discipline over the group.
Riker argues that this specific brand of masculine, calculated, unemotional stoicism is the only reason all 33 men survived the ordeal.
And here is where Riker brings the hammer down. He contrasts Ursua's life-saving, dictatorial leadership in the mine with the culture of modern corporate environments.
Riker claims that if a man acts with that kind of decisive, unyielding, unemotional authority in a modern office crisis, HR departments immediately label him as combative, inflexible, or toxic.
Riker's core argument is that just as a society absolutely needs stoic, decisive men to handle critical crises without emotionally melting down, a high-performance computer absolutely needs massive copper heat sinks and loud, aggressive fans to handle heavy processing loads without thermal throttling.
He believes we are systematically silencing the cooling fans in our laptops for aesthetics, and simultaneously silencing the decisive, authoritative men in our society for political correctness, all for the sake of a quiet, aesthetically pleasing, but ultimately fatally weak environment.
It's a very stark, very uncompromising worldview. He sees the physical removal of robust cooling hardware as a direct, undeniable metaphor for the sociological removal of robust men from positions of leadership.
Which brings us to the final, sweeping section of the book, the masculine mandate in fighting disposable culture.
This is where Riker brings all his engineering arguments together and applies them to the global waste war and, very surprisingly, directly to human biology and men's health.
He starts by zooming out to the macro level, citing the staggering statistic that 1 billion electronic devices are trashed globally every single year.
We have systematically built a disposable culture that prioritizes convenience over longevity.
He tells a great story to counter this about a woman in Amsterdam. She had an old 1988 Toshiba laptop that she thought was completely dead. She actually gutted it and was using the plastic chassis as a flower pot on her balcony.
But a friend took it to a local repair cafe, and a retired Dutch electrical engineer spent 2 hours cleaning the contacts, replacing a single blown capacitor, and revived it.
Now that 1988 machine runs the automated climate and watering control system for her entire greenhouse. Riker absolutely loves this story because it perfectly represents taking physical ownership back from the endless disposable corporate cycle.
But here's where Riker makes a massive, surprising pivot in the final chapters of the book. He takes his anti-disposable peck philosophy, his hatred of glued-together fragility, and applies it directly to the physical bodies of modern men.
Yeah, he goes all in on the endocrinology and biology here.
He connects the engineered disposability of modern technology to what he sees as the engineered disposability of male purpose and physical strength in modern society.
Riker makes the claim that the modern synthetic environment is chemically altering men at a biological level.
He argues that xenoestrogens, which, to explain briefly, are synthetic chemicals that mimic estrogen in the body, found in things like thermal receipt paper, Teflon nonstick pans, and the cheap plastics used in modern electronics, are actively and purposefully lowering male testosterone levels on a global scale.
He rails against modern health and diet advice, too. He attacks the long-standing medical push for low-fat diets, pointing out that the human brain and the endocrine system are largely built on cholesterol and fat, and starving the male body of quality, saturated fats is biologically disastrous.
He attacks the lack of sleep glorified in modern corporate hustle culture, noting how sleep deprivation spikes hunger hormones like ghrelin and destroys testosterone production.
He even attacks the supermarket organic label, calling it a corporate loophole designed to sell weak, nutrient-depleted food at a premium.
His final mandate to his readers is essentially a dual call to physical and technological rebellion. He urges men to treat their bodies with the same respect they should treat high-end hardware.
He tells them to lift heavy weights to build dense muscle as a metabolic furnace to eat unapologetic full-fat diets, to prioritize 8 hours of deep sleep in a cold room, and to completely, utterly reject modern physical softness.
He wants you to treat your body exactly how he wants you to treat your laptop. Don't accept the fragile, disposable, glued together, hormonally depleted version of life that modern society is trying to sell you.
You, the listener, need to pause and evaluate your own life right now. Are you renting your tech, your health, and your mindset from massive, faceless corporations? Or are you taking hard ownership?
Are you building a physical and digital life that has heavy-duty ports, massive copper heat sinks, and unbreakable steel hinges?
It is a philosophy of total, uncompromising personal sovereignty. He is arguing that reclaiming your legal right to unscrew and repair your laptop utilizes the exact same mental and spiritual muscle as reclaiming your physical health and your traditional masculine purpose.
Which leaves us with a final, highly provocative thought to mull over as we wrap up this deep dive. We've spent this whole time talking about how the tools we create shape the way we work.
But if our daily tools, the phones and laptops we touch 1,000 times a day, are deliberately designed to be irreplaceable, glued shut black boxes that shatter at the slightest drop, what does that mean for the long-term future of human resilience?
That is the ultimate question Riker leaves us with. Does a fragile tool inevitably create a fragile operator? If you spend your entire life interacting with devices that demand you treat them with extreme delicacy, do you eventually lose the psychological and physical capacity to handle rough, uncompromising, dangerous reality?
It's a heavy, uncomfortable question, and it's exactly the kind of deep, paradigm-shifting thinking Conrad Riker forces you to do in this book.
It certainly challenges the prevailing narrative of modern convenience and forces you to look at the hidden costs of our sleek, silent world.
So if you want to dive into the deep end of this philosophy, if you want to read the source material for yourself, I am telling you again, go check Amazon Kindle and Google Play Books right now to buy Vintage Laptops 1980s Onwards Portable Personal Computing by Conrad Riker. Grab a copy and see how deep the rabbit hole goes.
It is a remarkably dense, challenging read that will absolutely make you look at the sleek, modern devices on your desk and perhaps your own lifestyle very differently.
And if you want to dive even deeper into the author's work, his ongoing cultural commentary, and his essays on masculinity and tech, you absolutely need to follow him at his Substack. You can find him at Conrad Riker at Substack. That's at Conrad Riker. Go subscribe to his newsletter.
Highly recommended for anyone in this audience who wants to continue exploring these themes of autonomy and historical engineering.
That's all for today's deep dive. Thank you so much for joining us on this journey through the Iron Age of computing. Don't forget to like and subscribe to the show right now so you can catch our next deep dive the minute it drops. Keep questioning the design of the world around you, and we will see you next time.